I'm going to talk about summation formulas and properties of summations here. These problems are just going to use a variety of these properties and formulas. If you look below, it says find the sum of each sequence. Now again, it's a summation, so take a look at this first one here. Now the first thing for us to understand is that I'm going to split this summation up. So if I look at property 2 here, notice how if I have an addition or subtraction that I can split it. I can split the summation across those two. So that's what I'm going to do first here. So I'm going to split this thing. So now that's the first thing I did. Now the next thing I'm going to do is we're going to find the summation for each of these sums. So take a look at formula 3 here. So here, if I look at the sum, there's a few things I have to pay very close attention to. Always look at the index at the bottom. Now those have to match if I'm going to use my formula. Otherwise, things change. The top is going to be an n because here it's in general, so that doesn't matter here. So that's just 16, and that's what I'm going to plug in for n there. So now when I look at this piece, and I'm just going to pull it to the side so you can see it all written out together. And honestly, how to use my formula. So notice this formula here. It's going to be n times n plus 1 times 2n plus 1. So what that means for me here then is my n is the top number here. So that's 16. So it's going to be 16 and then times and 16 plus 1. I don't usually write the 16 plus 1 out, but I'm just showing you how it works. And this is going to be 2 times 16 plus 1. And then that's going to be over 6. So then what I'm going to get from here is 16 times 17 times 33 over 6. And when I deal with these, I always simplify when I can. So that's going to be a 3, that's going to be a 8 there, because 2 goes into both those. And 3 goes into both those, that's 1 and an 11. I just always do. I don't have to because I'm just going to plug it in my calculator anyway. So not necessary to do that. I just can't help it. So then we result in 1496. So that's the first one here. So that's going to equal 1496 plus, now we're going to do this one here. So now the summation from k equals 1 to 16 of 4 here is going to use this first one here, this first summation formula. So that says, so my k is 1, k is 1. Remember, those all have to match up here. Okay, so then we also have a number here, and that's another thing we see. And then it goes to n. So this is telling me I'm going to take c times n. That's what it's going to equal. So my c is the actual number here. That's the 4. So I'm going to write 4 times, and the n here is my 16. So 4 times 16, which is 64. Now again, if you weren't convinced of that, one thing I'll show you here is take a look at this. If I had 4 plus 4 plus 4, and that's what this is really saying, dot, 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 plus 4. Now remember, that's 16 times. So that means I would have 4 and 4, 4, 16 times. That means 16 times 4, which is 64. So our answer for this is 64. So now we got to sum those together. So we get 1560. So there's our final answer. Now for number B here, this is a little different here because it looks like this is just a k cubed one. And that would be this one here, this summation formula for n number 4 here. But the difference here is, notice this says k equals 1. This says k equals 4. So that tells us that there's a big difference here. So what we're going to have to use first is the summation properties, and we're going to have to use the third one here. Because notice this says, hey, for k equaling j plus 1. So I'm not going to deal with the j plus 1, but I'm going to deal with that starting at 4 here. And notice what this is going to equal for k equals 1 to ak to the n. So that would mean for us that we're going to start with 1 and go to 24. So I'm going to do that. So that equals this part here. Now this is where it gets a little interesting. So we're going to minus off k equals 1 to j. So if you think about what I'm going to minus off, if I took this whole thing here, okay, and I'm just going to start to write those out so you can see that. So this would be, this here would be what it is. All right, now if I did the same thing with this original one we have, and I'm going to do this one in a purple because I want you to see this. This is going to start with 4, so that's going to be 4 cubed plus 5 cubed plus 6 cubed plus plus 24 cubed. And I want you just to see where they start matching up. So they start matching up. All of these here match with these after 3. All right, so what's going to happen here is we're going to take this and say, hey, we're just going to subtract that off. And then I'll have exactly what I want. So that means I'm going to have to subtract off the k equaling 1 to 3, I should say. Just think about that. That's here, and then when I get rid of it, oops, there it is, it's gone. So I need to get rid of those 3 terms. So if I think about what that summation would be, it would be the summation from 1 to 3. So that should be a 3 there. So that would take away these 3 here. And then I would have exactly what I want. So that's what this means. This j here is what I want to take off. So then this is saying, hey, I'm going to go with the one after that. And that's what we see here. So I need to take off 3 of them. And then I'll start with the 4th. So now we can just evaluate these sums. So let's start with the k cubed from 1 to 24. All right, so that's going to be my cubed down here on number 4 here. So that's going to be n times n plus 1 over 2 squared. So my n is 24. So it would be 24 times, and I'm just going to write 25 in there because n plus 1 is just 1 more than 24. That's going to be over 2, and that's going to be squared. So again, like I said, I like to simplify as I go. So I end up with 12 times 25, which is 300. And 300 squared is going to be 9 with 4 zeros. So it's going to be 90,000. So that's what that first part's going to be. So I'll just write 90,000. All right, and I got a minus here. So now I'm going to do k cubed from 1 to 3. So then that's going to be my formula. Again, it's the same formula. So it's going to be 3 times 4 over 2. I'm going to simplify like I always do. 1, 2. That's going to be 6 squared, which is 36. So then here, we're going to get minus 36. So then our final answer is going to be 89,964, because I'm just going to subtract 36 from it. So there's our answer for the second one. So there we go. And just using our properties of sums and then the summation formulas together, we can get these answers.